Hey there team, how are you? We are going to be looking at mixed numerals again. We are going to be looking at evaluating mixed numerals, which really means we are going to be looking at adding and subtracting mixed numerals. And you can probably see that I've got two videos filmed just prior to this that look at adding and subtracting mixed numerals. And I guess that today we're going to be looking at doing those both together. So here's some success criteria with regards to adding mixed numerals. We would have converted 3 1/5 and 2 1/3 into a common denominator of 15, and then we would have added them together. That's what an addition one might look like. Here's what a subtraction one might look like. Again, we would have converted these uncommon denominators into 30ths and then completed the sum. Now, that's where we're headed today. If you need to learn more about that, come along with me. We're going to be looking at mixed numerals, addition and subtraction all together. Let's go. Here we go. I'm going to show you how to do this one. We're going to evaluate it, which means we're going to solve it. We're going to evaluate it, which means we're going to solve it. And I'm going to show you, and then you can have a go all by yourself. First of all, guys, we've got 2 2/3 plus 6 4/5 here. Very good. But look, there is an issue. There are uncommon denominators. That's not going to work for us. There are uncommon denominators. You can't add thirds to fifths, so we're going to have to convert to the same denominator. My solve there would be I would be converting to 15ths, because I know that 3 goes into 15 and I know that 5 goes into 15 as well, because 3 times 5 actually equals 15. So let's do that. Let's convert 2/3 and 4/5 into 15ths. Okay, so let's times 5 by 3, of course, which gives us the 15. We've already done that. And whatever with fractions, when you're making equivalent fractions, whatever you do to the bottom, you've got to do to the top. So 4 times 3 equals 12. So that's, I guess, 12/15. Okay. Now with 3, it's 3 times 5 gets you to 15. We've already done that. So with fractions, when you're making equivalent fractions, whatever you do to the bottom, you got to do to the top. So 2 times 5. Now that equals 10, so that's 10/15, which is another way of saying, guys, that just hang on with me because I'm not going to pause the video. Which is another way of saying that 4/5 equals 12/15. They're equivalent. 2/3, guys, equals 10/15. They're equivalent. So we've just changed the denominators here. We've changed the denominators into 15ths, so they're now what are called common denominators. So the sum's much easier to complete. The sum now becomes 2 10/15 plus 6 12/15, and that's much more manageable. So let's just rub this out, because we don't need that now. Can I please rub it out? Okay, so our sum now is 2 10/15 plus 6 12/15. Now, guys, I've told you about this before, and I'm happy to tell you again. Let's add the fractions first. And so if we can just sort of forget about the 2 and the 6 for a while, let's just add the fractions first, and you'll see something quite interesting straight away. If you add 10/15 to 12/15, well, 10 plus 12 is 22, yeah? So you actually get 22 over 15, which is an improper fraction, and you need to convert. And we're not going to be dealing with improper fractions today. We're going to change them into mixed numerals. So 15 into 22, well, 1/15 goes into 22, doesn't it? And there's 7 remainder. So our mixed numeral will be 1 7/15. So fraction-wise, guys, 10/15, right, plus 12/15 equals 1 7/15, which means we can now bring in these whole numbers, well, let's do this, okay? Let's bring in the whole numbers, because we've done the fractional bit. Let's bring in the whole numbers. So that's 2, right, plus 6 plus 1 7/15. So our final answer will be, well, 2 and 6 is 8, plus the 1 is 9, plus the 7/15. So that's 9 7/15. And you cannot simplify that down any further. Okay, I've already made some videos showing you this, which I'm fine for you to go back and have a look at. They're very recent. I think adding mixed numerals with uncommon denominators, but I'm going to give you a go by yourself anyway, so please have a go now by yourself. I'm going to write you one. Here it comes. Here's one for you to do all by yourself. You can do, there you go. 6 and 19/20 plus 7 and 4/6, and can I guarantee when you do this, first of all, you're going to have to you're going to have to make them common denominators, okay? You can't add 20ths to fifths, you're going to have to make them common denominators. Denominators, you're going to have to do that. 2, you're going to have to, you're going to need to add the fractions together once you've made them common denominators, and you're going to find you're going to have what is called an improper fraction. So you're going to have to make that improper fraction into a proper fraction, okay? And then once you've done that, you can add it all together. And you may need to simplify, I'm not sure yet, but you might need to simplify. Okay, so it's your go. Have a go at this question here. Okay, pause me and have a go. Okay, I hope you paused me, and I hope that you went like this. I hope you went, 5 goes into 20, so we're going to make the 20ths, and we're just going to keep this as 20ths. That's fine. So that's going to stay as 19/20ths. But 5 times 4 equals 20, so whatever you do to the bottom, you got to do to the top. So 4 times 4 would equal 16. So the new sum becomes 6 and 19/20ths plus 7 and 16/20ths, which actually gives us, 19 plus 16 is a bit like saying 20 plus 16, but minus 1. So 20 plus 16 is 36. So it's going to be 35. So that's 35. 20. Oh, sorry. So I'm just adding the fractions first. So fractionally, just adding 19/20ths to 16/20ths, the answer is 35/20ths, which I'm not happy about, guys. That's actually an improper fraction. So let's convert that from an improper fraction into a mixed numeral. So 20 into 35 actually goes 1 with 15 remainder. So that's 1 and 15/20ths. So that's fine. 1 and 15/20ths is a much better answer. Equals 1. Oh, sorry, can I get my pen back? 1 and 15/20ths. And now we've answered the fractions, so good for us. We've added the fractions together successfully. Let's add the whole numbers. 6 plus 7 is, of course, 13. Right, so that's, I guess, whoops-a-daisy, sorry. That's 13 plus 1 and 15/20ths, which equals, right, 14 and 15/20ths, which, thanks very much, you can simplify, can't you? And of course 15/20ths can be simplified to 3/4. So I guess your final answer is 14 and 3/4. Okay. Let's have a look at a subtraction one, which I think are much easier. You're not going to be dealing with improper fractions and the rest there. Let's have a look at a subtraction one. Here's one we might look at. Here we go. Let's call this one. Here you go, 8 and 8/10 minus 2 and 1/4. So we're going to evaluate this. Let's find the answer to this. And I'm just going to show you, we're in the teaching phase now. I'll just show you. Look, guys, once again, let's work with the fractions first. It's always the fractions first. We can't take a quarter away from a tenth. They need to be the same language. Let's put them both into the lowest common multiple, the number they can both go into. And so they'll actually both go into the number 20. That's the lowest common multiple for them both. 4 goes into 20 and 10 goes into 20. 4 goes into 25 times, so 4 times 5 equals 20. Whatever you do to the bottom, you've got to do to the top. So 1 times 5. So there's your equivalent fraction. 10 goes into 20 twice, doesn't it? So 10 times 2, which is the 20 there, and 8 times 2, which is 16. So there you go. We've successfully created equivalent fractions. Okay, hooray for us! They're your equivalent fractions. 1/4 equals 5/20ths. 8/10 equals 16/20. Good. So our new sum is really 8 and 16/20 take away 2 and 5/20. Hey, let's do the fractions first. This is way easier, isn't it? 16/20 take away 5/20 is, of course, 11/20, right? and then you can do the whole number bit. 8 take away 2 is of course 6, so your answer is 6 and 11/20. Okay? Hey, you can't simplify that either, can you? That's as simple as it gets. I'm going to give you one to do. Here you go. Here's one that you can have a go at. Let's call this one 15 and whoopsie daisy, 4/5, right? Take away 12 and 1/3. You can have a go at that one for me. Okay. Please pause me and have a go. Please pause me and have a go. Right, evaluate this. I hope you've paused me. I hope you went, I can't do 5 and 3. I'm going to have to put them into I'm going to need to make them common denominators. Let's make them 15 because 5 times 3 equals 15. So that's always guaranteed. That's an easy one for us. Just times that. By that, you'll get if you times the 5 by the 3, you'll get a common denominator for sure. Okay, so whoopsie daisy. So in doing that, 3 times 5 obviously equals 15, right? And so whatever you do to the bottom, you got to do to the top. So 1 times 5 equals 5. So there's that. And 5 times 3 equals 15. And whatever you do to the bottom, you got to do to the top. So 4 times 3 equals 12. So there you go. We have our equivalent fractions now. Ta-da! And I wonder if that's what you did. It's really important that you did do that. Because just to state the obvious, which is really important to state, 4/5 is equivalent to 12/15, and 1/3 is equivalent to 5/15. We've just turned them into common denominators, so we can add them and subtract them and do all sorts of fun things with them. So we've done that. So the new question is 15 and 12/15 take away 12 and 5/15, which actually equals, well, like I said, let's do the fractions first, shall we? 12/15 take away 5/15 equals 7/15. Yep. And then let's do the whole number. 15 take away 12 equals 3. So there's your answer. 3 and 7/15. And actually, we can't simplify that down any further. That's as simple as that goes. However, can we pretend, let's just pretend, world, if that answer was 3 and 5/15. It could be simplified to 3 and 1/3. But because 5 divided by 5 is 1 and 15 divided by 5 is 3. But the answer is not 3 and 5/15. The answer is in fact 3 and 7/15. 3 and 7/15, which will not be simplified. Okay, this has been Teach Together Try. We've been looking at evaluating mixed numerals, and by evaluating, I just mean we've been adding and subtracting them. Okay, and that's the task for today. See you later.